show that if the diagonals of a quadrilateral are equal and bisect each other at right angle, then it's a square. So again, I'll be drawing the diagram. So since we have to prove things are square, so let's draw a square. So here it's very clear that the diagonals are equal and they are bisecting at an angle of 90 degree. So if we consider ABCD and point of intersection is O, right? So please write the description of the diagram. What is that we need to prove? Consider a quadrilateral ABCD with diagonals AC and BD. Intersecting at O. This implies, okay, so no. If the diagonals of the quadrilaterals are equal, it's given that AC is equal to BD. We can call this as 2x. Then they bisect each other. Diagonals bisect each other at O. This implies AO is equal to OC, BO is equal to OD. All of this are equal to half of AC by 2, BD by 2. So all this are equal to x. So all these lengths are equal to x, 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 x and x. Then also third thing that is given is at right angle, that is diagonals meet at 90 degree. So we can tell angle AOB is equal to 90 degree. There are quite a few angles, so let's not write all of it. So this is all the things that is given. So end of it, what is that we need to prove? ABCD is a square. So to prove something is a square, what is that we need to prove? All the sides are equal, and if I prove that the angles are 90 degree, we are pretty much done. Now one of the angle is 90 degree, we are done. So how to prove is the next thing that we need to think about. First thing first, we'll prove opposite sides are equal. Quite simple. Consider triangle OAB and ODC. AO is equal to OC, OB is equal to OD, and angle OBD is equal to angle DOC, vertically opposite angle. And these things are given. So what can we tell? Therefore triangle OAB is congruent to triangle ODC by SAS congruency. So therefore AB is equal to DC by CP CT. This is actually CD. So similarly we can prove that AD is equal to BC. Similarly we can prove triangle ODA is congruent to triangle OBC. Thus, AD is equal to BC. So we have the opposite sides to be equal. Now, if I prove that two adjacent triangles are equal, congruent, then all the sides are equal. So now let's consider this 2 or this 2. Consider triangle ODC and triangle OCB. ODC and OCB. OC is common. Then we have OD is equal to OB, that we already know. And we have DOC. Angle DOC is equal to angle COB. As diagonals are, what is the statement? Are at 90 degree. Or at right angle. So all these are equal to 90 degree. So by what can we tell? Therefore by SAS congruency, triangle OCD is congruent to triangle OCB. So these two triangles are congruent. So basically we can tell that CD is equal to CB, CP, CT. So from equation 3, 2 and 1, all the sides are equal, right? So this is something that we'll conclude later. So we proved that all the sides are equal. So we are half the way, telling that it's a rhombus, if not a square. To prove that it's a square, we need to prove that the angles are equal to 90 degree. So how do we do this? Well, we have this particular angle. If I call this as, say, theta, this is also theta. Why? We just proved that. So these two are theta. Okay, so if this is theta, this is also theta, since this is 90, right? So we can prove that, this two will add up to, this two will be equal to 90 degree. So let me do that. Actually, let me prove that one of the angle is equal to 45 degree. Then it becomes simple. Again, there are quite a few ways of doing it. As of now, this is what I'm feeling like doing. So I'm going with the flow. So angle OCD is equal to OCB. OCD is equal to angle OCB, which we can call it as theta. Again, CP, CT. Right? Now consider triangle, the bottom triangle ODC. ODC, here OD is equal to OC. It's given, right? So all of these are equal to X. Therefore, angle ODC is equal to OCD. ODC is equal to angle OCD, which is equal to theta. Reason? Opposite angles to equal sides are equal. So with the help of angle sum property, angle ODC plus angle OCD plus angle DOC is equal to 180 degree. So angle sum property. So this one is how much? This is theta, this is also theta, and this is 90 degrees. So this is equal to 180 degree. So solving this, 90 divided by 2. No, that's it. So 2 theta is equal to 90 degree, right? Thus DCB will be equal to 90 degree. This implies angle DCB is equal to 90 degree, as angle DCB is equal to angle DCO plus OCB. Angle OCB, which is equal to theta plus theta, which is equal to 2 theta. So from all of this, from 1, 2, 3, 4, since from 1, 2, 3, we have proved all sides are equal, and from 4 we have proved the angle is 90 degree. Thus ABCD is a square. Hence proved. Right? So this is your answer.